Hi everyone, I will be presenting the work submitted to DCASE 2021 workshop entitled Diversity and Bias in Audio Captioning Datasets, done with Annamaria Mesaros. I will start with the motivation behind this work, followed by the collected dataset. Then I will introduce diversity, bias, and similarity concepts studied in the paper, and I will conclude with the results and conclusions of the work. What motivated this work is to better understand the acoustic scene using sentence descriptions and to see how much the annotator's opinion is influenced by the instructions of the given task, studying how much diversity there is in the descriptions. Therefore, in order to do that, we evaluated the bias present in the annotators, the lexical diversity present in the collected captions, and we released the captions dataset. An audio caption can be defined as a sentence where the annotator expresses the human perceived information of a soundscape. In this figure, there is represented the acoustic scene classification as airport, with the audio tagging performed by 3 different annotators and their corresponding audio captions, showing 3 different ways of describing the same acoustic scene. The collection of the dataset was performed using a subset of TAU Urban Acoustic Scenes 2019, given to the 133 students 10 seconds clip to select the predefined audio tags and write a free-form sentence description. A total of 3,930 files were annotated by 5 different annotators. After collecting all the captions, a set of post-processing steps was performed in order to clean the data and remove possible grammatical errors. The punctuation symbols were removed and symbols were replaced by their written form. In some cases, we also applied lemmatization and stop word removal. Apart from our collected dataset, MAX, publicly available in Zenodo, we also studied the diversity and bias of other 2 datasets. One is AudioCaps, the largest captioning dataset with almost 60,000 audio clips, and Clotho, smaller than AudioCaps, but where audio clips were described by 5 different annotators. To study how auxiliary information may affect the human-produced captions during the annotation process, we start by analyzing the lexical diversity. One simple measure is the type-token ratio, often used in measuring language acquisition in infants or learners of a foreign language. It is defined as the number of distinct words, tokens, divided by the total number of words, 1 meaning not repetition at all, and 0 an infinite repetition of the word. In this table, we can see an example of how it has been calculated for the different captions. Next, we propose to measure the bias present in the vocabulary as the proportion of hinted sounds with respect of the number of sounds mentioned in the caption. In this scenario, we only analyze AudioCaps and MAX, since they are the ones that provided hints during the annotation. For MAX, the hints are the 10 predefined tags, while for AudioCaps, these hints are the tags associated to the clip in AudioSet. From AudioSet vocabulary, we add our own tags as well, since, for example, there is no talk and only speech present in the vocabulary. We calculated the tags and word bias independently, since some of the tags are formed by more than one word. Results confirm the influence of the given hints in the choice of words. Finally, we want to study how similar are the descriptions by different annotators from the same item. We use metrics from machine translation in order to calculate that. One basic approach is the use of Jacquard similarity coefficient, which is insertion over union. And another popular metric is BLEU, bilingual evaluation under study, which calculates the overlap between n-grams from the reference and candidate sentences. Cannot handle synonyms and paraphrasing. We can see it in the example. how the last sentence has higher blue, but is the one that is most incorrect compared to the reference ones. Recent methods make use of pre-trained models with large amount of data, able to handle synonyms, paraphrasing, and different ordering. One example of this is BERT. The figure is an example of the BERT score, how goes token by token encoding calculating the similarity. Sentence BERT is a modification of BERT using Siamese networks encoding the whole sentence instead of going token by token. Here we can see the results for the lexical diversity. We have calculated overall, considering the whole dataset and also locally, defined as the diversity present in the captions belonging to the same item. But we haven't calculated for audio caps. We calculated for 3 different scenarios considering removal of stored words and lemmatization. We show also which are the most used words in each dataset, and it reflects how different the nature of Clotho is, where the clips are selected specifically to not include speech. Considering stop word removal and lemmatization, we calculate also the moving average type token ratio, another metric for calculating diversity, but fairer since it's independent of the text length and depends only on the window size. Audio caps has higher diversity when the moving average TTR is calculated using relatively small windows, from 10 to 1000 tokens, while for larger windows, Clotho is more diverse. In all cases, Max has a smaller moving average TTR diversity, showing a high repetition of the vocabulary. Finally, we show the similarity of the captions produced by different annotators. In the figure is represented the histogram for Max. We can see how blue provides the lowest values. In general, for these 4 metrics, Max shows higher diversity, while Clotho sentences seem to have more words in common for the same audio clip. This work studied the lexical diversity, bias, and similarity of captions from 3 different datasets. Regarding diversity, we see how a small set of words is used repeatedly in the captions. Regarding bias, it is proved that the given hints affect the free text description to some extent. While studying similarity, we see that the semantic similarity between captions is quite high. We can conclude that the complexity of the soundscapes affects more the free text description than the given hint. And for future work, we hope that with the release of the new tag caption pair dataset, a guided captioning with a measure of truthworthiness for each caption will be used in the learning process. Thank you, and I'm looking forward to see you all in the DCASE workshop.